All right, my MathCounts people. Here we go. So I go ahead and teach this lesson every year. So if you're an eighth grader, I'm sorry you're going to hear this again. But I've always seen combinatorics on pretty much every single MathCounts competition test. So it's something good to cover. So combinatorics is just how we can find combinations from different items. So when we're looking for how many combinations can be made from any number of items, the number of combinations is equal to n factorial, which means if we've got 5 different items, 5 completely different items, that the number of combinations that can be made are 5 factorial. 5 factorial simply means 5 times 4 times 3 times 2 times 1. So 5 factorial just means all the numbers from 5 and below, all whole numbers from 5 and below multiplied together. Now the reason is, if we have 5 items and we've got 5 places to put them in, it means that the first item that we're going to plug in, well, there's 5 different items, so there's 5 choices. The second item, well, now there's 4 choices because we've already used one of them. And then the third item, of course, there's 3 choices because we've used 2 of them so far. Then there's 2 for this one. And then we only have 1 item to put in the last one. And so when we have 5 choices, 4 choices, 3 choices, 2 choices, 1 choice, so there's a multiplication effect that happens at this point to find the number of combinations. So that's why it works. So how many distinct combinations can be made from the letters A, B, C? Well, there's 3 items, so we've seen that it's 3 factorial, meaning that there are 3 times 2 times 1. There are 6 different ways that we can do A, B, C. And we can actually see the 6 different ways we can do that. Like if we have A as our first one, then we could do B, then C. Or we could start with A and then do C and then B. So a different order of those 3 letters. Okay, so that's all the ordered combinations that we can do starting with A. And then you can do the same thing with B. You could start with B and then have A and C, or you could start with B and then do C and A. And then that's all the combinations with B as the starting letter. And you've got C could be A then B, and then C could be B then A. That's all the combinations that you could make from 3 distinct items. And there's 6 combinations there, which we knew was going to happen because it's 3 factorial. All right. So if you've got 10 items, then there are 10 factorial ways to rearrange those 10 items. Okay, repeating items. So n is going to be the total number of items, and then r is the number of times that it's going to repeat. So we're going to have n factorial divided by r factorial. What's going to happen here is we're going to have double counts in there. So we have to divide out all the things that have been double counted. So in this instance, we have 4 items, 4 factorial. So we could do 4 times 3 times 2 times 1, but 2 of those items are being repeated. O. So what happens when we have 2 items that are repeated is some combinations, so food can be spelled with F, the first O and the second O, and then D. Or we can do it as F with the second O, then the first O, and then the D. These are the same thing. One's the second O, one's the first O, but they're really the same thing. There's no indication on which is the first O. So these combinations are exactly the same. So we're going to have a lot of repeated combinations in there. And so what we're going to do to get rid of those repeated combinations is divide out the number of things that are being repeated. So there are 2 O's that are being repeated. So the repeated items, there's 2 of them. So we're going to do 4 factorial divided by 2 factorial. So what we can do with this is actually a really quick way to do these, we don't have to really worry about the 1 there. We can see that we start reducing out numbers, and we get 4 times 3 is 12. All right, next one. Two-toe. Okay, there's 5 items there. But we have 2 different repeating items. The T is repeated twice. The O is repeated 3 times. So I'm going to divide out both of those combinations there. Now, one thing that you can do is, before you start writing everything out like this, the 3 and the 5 are going to reduce so that on top you're left with 5 times 4. Because remember, this is 5 times 4 times 3 times 2 times 1. The 3 times 2 times 1 is being reduced by the 3 factorial, leaving us with only the 5 and the 4 in the numerator. And then this is 2 times 1, so divide by 2. 10 would be our number of combinations. So since there's a bunch of repeating combinations, even though we have more letters here, we have less combinations because of the repeaters. All right, let's flip it over. Backside. All right, picking a number of items. So if you don't want to pick every single thing, like if we were doing food, but we only wanted to pick 2 of the 4 letters, that's something a little bit different. This is what we call a combination. Oh, sorry, just drink some coffee and having some problems there. Anyways, so we've got the combination. These are the total number of items. And since we're not picking everything, what we're going to do is R factorial would be the number of things that we are picking. And then n minus r, so total number of items minus that, factorial would be down here. And I'll explain what that means in a second. All right, so we have 5 choices for a side dish for dinner, and we're going to just assume they're all different. And we only want to choose 2 of them. Okay, how many combinations can be chosen? So we got 5 different items. So our n in this case is 5. But we only want to choose 2 of them. All right, so I got 5 different things. I want to choose 2 of them. So in my numerator, I've got 5 factorial. But I only want to choose 2 of them. So this is 5 choose 2. So 5 choose 2. So r is 2, so I'm going to do 2 factorial. These are the 2 things that I'm choosing. Okay? Which means I'm not choosing 3 things. So this would be the 3 factorial right there. So it's kind of like you've got the number of items, and then you're going to divide by the things you are choosing, and then the things you're not choosing. So here, again, we can reduce right here with the 5 and the 3. So that we've got 5 times 4, and then 2 factorial is 2, reduces. So there's 10 ways that you can choose 2 out of 5 items. So this number is always going to be the number of things that you chose, and this is going to be the things that you didn't choose. Now, if we decided to choose 3 items instead of 2, we'd actually get the same answer, because then we'd have 5 factorial over 3 factorial, 2 factorial, which is exactly the same thing as this one here. So choosing 2 items and choosing 3 items will give us the exact same total number of combinations. All right, there are 8 hiking trails in the park, and you want to hike 3 of them. How many combinations can be chosen? All right, so n is 8. The number of things we're choosing is 3. So this is 8, pick 3. So we're going to do 8 factorial as our numerator. We're picking 3 things, which means we're not picking 5 things. We would reduce first. The 5 factorial would go away. In the numerator, we'd have 8 times 7 times 6, and then everything after that is 5 factorial, so that's gone. And then we've got 3 times 2 in the denominator. 3 times 2 is 6, so these cancel out, and we're left with 56 as our final answer. So there are 56 ways to take 3 hiking trails out of 8. Now you're also going to get 56 ways to choose if you take 5 hiking trails instead, because you're still going to have 3 factorial, 5 factorial in the denominator. All right, that's all I have for you. There is some more advanced combinatorics that you can do, especially with sticks and stones. You have to remember when you do combinatorics that sometimes you have to really look into the problem and go, okay, there's different cases. Like maybe I could only pick 2, but then there's another instance where I could pick 3. So you have to look at different combinations. But this is like the basic starting point. A lot of the problems have a lot of different things you can do, but it will all be based off of this general idea of factorials. All right, that's all I got for today. Pretty easy one. All right, see you later. Bye-bye.